How to get the greatest common factor of a polynomial. So before we're going to proceed, let's have an example first. We have 5x squared minus 10x cubed. Okay, that's it. So let me explain now. First, to get the GCF of a polynomial, we need to find a factor that is common to all terms of the given polynomial. So this is our given polynomial, 5x squared minus 10x cubed. So we need to find the common factor, okay? So to do that, we need to express each term into prime factors by writing the prime factored form of the numerical coefficient of the term. So when we say numerical coefficient, we're talking about the numbers. So what are the factors of 5 and 10? So we have 5, of course. Next, if you notice, we have variables. When we say variables, these are the letters given in the polynomial. So for the variable, we need to choose the least exponent on that factor that appears in any term. So here is the first term, here is the second term. So if we notice, we have x as the term. So as I had mentioned a while ago, the least exponent. So x squared and x cubed, the least exponent is x squared. So x squared. So that's how we get the GCF of a number. Okay, so let's have another example. X squared plus 2x. So in here, we have, what are the given number first? So in the first term, we have 1. So maybe you're asking, where is the 1? So if there's no number written like the first term, it is automatically mean that the number here is 1. Okay, and 2. Of course, the common factor of 1 and 2 is there any? Of course, 1. So no need to write it. And the variable or literal coefficient, x and x. So the least exponent is, of course, x. Okay, so if you notice, x only, there's no 1 as an exponent. I will repeat, if there's something written on the top as exponent, that is automatically 1. Okay, so we have x. Therefore, our greatest common factor for x squared plus 2x is equal to x. Okay, another example, we have 25 x squared y 5 next plus 55 x y cubed. Okay, so first we need to focus on the numerical coefficient. We have 25 and 55. So the factor for 25 and 55 is 5. GCF, guys. So 5. Next, we have x and x. Okay, both first term and second term have x. So x, the least exponent, 2 and 1. So just x. And another literal coefficient or variable, we have y, and the least exponent is y3. So y3. Okay, easy, right? Okay, let's have another example. We have 10c cubed minus 80c raised to 5 minus 5c6 plus 5c raised to 7. Okay, so I think this is quite long. Okay, so we will look for the numerical coefficient first and look for their factor or greatest common factor. 10, 80, 5, and 5. Of course, both of them are divisible by 5, so 5. Okay, and all of them have literal coefficient, which is c. So look at the exponent, 7, 6, 5, 3. So least exponent, so c, 3. Okay, and another example, we have 12m cubed and squared minus 6m squared and cube. Sorry guys for my penmanship. Plus 3mn. Okay, so 12m cubed and squared minus 6m squared and cube plus 3mn. Of course, look for the numerical coefficient, 3, 6, and 12. All of them are divisible by 3, and 3 is their greatest common factor. All of them have literal coefficient of m, and look for the lowest exponent, which is m. And all of them have n squared, n cubed, and n, so n. Okay, that's how we get the greatest common factor of a polynomial. Okay, maybe you're asking, what if one of the literal coefficient is not common to one of its term? Okay, let's have an example. 4m 5n minus 8m plus 10m cubed and squared. Okay, so how do we get this one? First, of course, we will consider their numerical coefficient. So 10, 8, and 4. So what number is their greatest common factor? So I think it's 2. Okay, so 2. Next, m cubed, m, and m fifth. Least exponent, so we have m cubed. Okay, how about n? First term have n, second term don't have, third term we have n. So are we going to consider n as part of the GCF? No. It's a big no. Why? Because the second term doesn't have n as literal coefficient. So our GCF here is 2m cubed. Okay? So that's how we get the greatest common factor of a polynomial. Easy, right? Okay guys, I hope you learned something from this video, and if you think that it's quite interesting and you learned something, please subscribe my channel. Thank you. Keep safe.